the next few application problems are special types where we can set up with the table, and you'll have to do at least one of these on the quiz, and almost always one shows up on the final exam. So these table cases, you'll notice this is whenever we're making something, we're building something, we're creating something. While we're creating something, we're using up different parts. We're using up, in this case, we're going to be using up eggs, sugar, and flour. Sometimes we're using up time it takes to build something. And we'll do examples where those are the cases. And so whenever we're building something like this, whenever we're solving an application where we're building something, we have using up materials, and they gave us we only have so much, right? There's only a limited supply of my materials. These are table cases. All right, so my first example here, which we're going to set up and use a table and then a matrix, and I'm going to show you where the equations come from the matrix, from the table to get to the matrix. All right, so a baker, Mario, is a cookie shop. He has 3 different types of cookies: chocolate chip cookies, snickerdoodle, and peanut butter cookies. Each of the cookie types require so many eggs, so much sugar, and so much flour. And they give you in each line there, the chocolate chip, 1 egg, 1 cup of sugar, 2 cups of flour. Snickerdoodle, 2 eggs, 1 cup of sugar, 1.5 cups of flour. Peanut butter, 1 egg, 2 cups of sugar, 2 cups of flour. The bakery has a limited supply of eggs, sugar, and flour. They have 60 eggs on this particular day, 75 cups of sugar, and 105 cups of flour. All right, the baker wants to know how many of each type of cookie can he make if he uses up all of his eggs, his sugar, and his flour. Alright, so I'm going to use a table in this case. Now, I'm going to let X, Y, and Z represent my different batches. So I'm going to let X represent my batch of chocolate chips, Y represent my batch of snickerdoodles, and Z represent my batch of peanut butter. Alright, so those are my variables. I define my variables. And then I'm going to set up the corresponding system of equations, but I'm going to do it using a table. From the table, I actually get my matrix, but I'm going to show you what the system of equations would look like. All right, and so the way we set up a table in this case, so it's always set up the same way. Across the top is what I'm creating. So across the top are going to be my variables, what we want to make. Down the side here is what we're going to use up, right? What we're using up. What we're using to create whatever it is, what we're making. Alright, so I've got 3 things, right? I've got eggs, cups of sugar, cups of flour, which should match up with some totals. That's my very last column is totals. Alright, and so what I have is, well, X, which will represent my chocolate chip. Y, which represents my snickerdoodle. Z, which represents the peanut butter. Right, that's what my X, Y, and Z were. Alright, so across the top is always your variables, X, Y, and Z. This is what I'm using up. My eggs, my cups of sugar, and my flour. And then I've got total. So I'm going to go put my totals in first, right? I have a total number of eggs. All right, that's my last row. Or sorry, my last column. I have a total number of eggs. So I'm going to put those in first. So eggs, I had 60 total to use. Cups of sugar, I had 75 total to use. And cups of flour, I have 105, right? Those are my total eggs. While I'm making my batches, I'm going to use up my 60 eggs, my 75 cups of sugar, and my 105 cups of flour. And that is flour. And so it's going to go with my variables. So, and I read down my list. So my X value, remember, represents the chocolate chip. Right? So my X, remember, is my batch of chocolate chip. Right? That goes with my X. And so when I'm creating one batch of chocolate chip, I use 1 egg, 1 cup of sugar, 2 cups of flour. Well, that's what goes down here, my values. This would be 1 egg. I've already forgotten what I said. 1 egg, 1 cup of sugar, 2 cups of flour. 1 cup of sugar, 2 cups of flour. For each of my X values, 1 egg, 1 cup of sugar, 1 cup of flour. And then I do the same thing for the Y. Alright, so the snickerdoodles, which are my Y, requires 2 eggs, 1 cup of sugar, and 2.5 cups of flour. And so those are the numbers that go down. So my snickerdoodles is 2 eggs, 1 cup of sugar, 2.5 cups of flour. So for each of those Y batches, 2 eggs, 1 cup of sugar, 2.5 cups of snickerdoodles. Then the last one is my batch of peanut butter. Alright, so my batch of peanut butter cookies requires 1 egg, 2 cups of sugar, actually that's hard to see, requires 1 egg, 2 cups of sugar, and 2 cups of flour. So I write those down. 1 egg for my peanut butter, 2 cups of sugar, 2 cups of flour. And what makes the table nice is this is your matrix already set up to go. This is your matrix. You plug into the calculator. It's a 3x4. So that's what you plug in. So across the top, row 1's 1, 2, 1, 60. Row 2, 1, 1, 2, 75. Row 3. Now, they do represent equations. Alright, so writing out the system of equations. And so I'm just going to write this out so you can understand. So this is a system of equations. The first row represents the eggs that are used up. And so the first row would be equation 1. 1x, 2y, 1z equals 60. So x plus 2y plus 1z equals 60. And that would be my eggs. And if you look at the problem, that's exactly how much eggs are being used up by each group, right? Every batch of my X, which is my chocolate chip, uses up 1 egg. So X of them will use up X eggs. My snickerdoodles use up 2 eggs, and so every batch of those will use up 2. And my peanut butter uses 1 egg. Alright, so every time I make a batch of those, I'm going to use 1. So Z of those will use up Z of them. Equals my total eggs. And then my next row is the cups of sugar. Alright, my first one is X, 1, and then Y is 1, and Z is 2, and it should add up to 75, and that's the cups of sugar. Right? All of my batches for my chocolate chip use up 1 cup of sugar, and so X of them will use up X cups. All of my snickerdoodles use up 1 cup of sugar, so if I make Y of them, they use up Y. All of my peanut butter uses 2 cups of sugar. Alright, so Z times 2 would use up all my sugar. And then the last row represents my flour. Right? I have total 105 units of flour, so cups of flour. Chocolate chip uses up 2 for each of the batch. Snickerdoodle uses 2.5 for each of those, and my peanut butter uses 2. And so there's my, and I didn't need my system of equation, but there's so you understand what my system of equations represent. What this table represents. This table represents this system of equation where X is my chocolate chips, Y is my batches of snickerdoodle, Z is my batch of peanut butter cookies. What's nice about the table is I actually don't have to have the system. Table gives me the matrix that I'm going to solve. And so then you just plug in your table as your matrix. Do your row reduced echelon form. So again, there's the table that you're going to plug in. You're going to plug in those numbers exactly they are in the exact same row, exact same column. And it'll solve the equation. And so when I do my row reduced echelon form on that, again, this is what I'm plugging in into my calculator. That would be my matrix A. When I do my row reduced echelon form on my matrix A, it will solve for my X, my Y, and my Z. Alright, so when I plug it in and I solve, it comes out 15, 10, 25. So remember, 15 is the X, Y, Z. And so that means they can make 15 of the chocolate chip batches, 10 of the snickerdoodles, and 25 of the peanut butters. If they do that, they'll use up all of their eggs, all of their flour, all of their sugar. All right, and so if they want to make the most of their materials that they have a limit on, they have a limit on eggs, flour, and sugar. Well, this is what they want to do. This is the batches they want to make. All right, next example we'll do on the next set of notes. So again, same type of problem, but we're going to set it up with an equation. So this is a table case. And so that's what the next couple of problems are going to be, because these are common ones. We like to do these. So you'll have one of these you'll have to do on your quiz. There'll be one on the final exam. All right, there'll be one in your homework.